Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online courses on engineering, drawing and computer graphics. We are in module number 3, lecture number 22. In the first two modules, we have learned about introduction to engineering drawings and conic sections. From lecture number 21, we are looking at orthographic projections, especially 3D objects. What is the best way to represent it on the drawing sheet? Such kind of two-dimensional plots from three-dimensional we call as orthographic projections. In the last class, we learned about projection planes and their pattern. For example, we define a plane as horizontal plane, which is lying parallel to the table. Other one is vertical plane perpendicular to the plane, and a profile plane which is on the side of this x y axis. There we learned about first angle projection, in which profile plane will be rotated by 90 degrees, so that vertical plane will be at top level, horizontal plane will be at bottom level and profile plane will be on the right hand side. So, by flipping this profile plane in that direction, we will construct a vertical plane followed by a horizontal plane and a profile plane. Based on the object where we are looking at, first of all one has to construct a frontal view. Usually in first angle projection, we construct this front view on the vertical plane. Just below that, a top view of the object will be there. For example, if I would like to construct a cylinder, this is the three-dimensional object and our view follows from this direction. If eye is from this direction, we would like to see the cylinder. The cylinder looks like a circle on that vertical plane. This is the front view, like a rectangle we will see. So, map this entire stuff onto this plane, so that we will get from bottom also one line goes in that way. So, this one, whatever the projection one, we call as front view here. If we are looking from top of that, the cylinder again follows another rectangle. This is what we call top view. So, on one side, let us call this is A, B. If we are looking from this direction, it looks like a rectangle. If we are looking from top, again that follows matched up coordinates top view. If we are looking from this side, on the side, we are looking from left direction all the way towards the right direction, then it looks like a circle. This is the circle what we are going to see. So, here we will see a circle. This kind of representation what we call first angle projection system, where the object is placed in the first coordinate and we are looking from left side towards right side. So, object or the projection will come on the right hand side and we are looking from left side. So, it is called left side view. These are the things what we have learned in the last class. So, in today's class, we will learn more about this first quadrant projections, third quadrant projections. In general, for any drawing sheets, two methods are popular. One is called first angle projection system, the second one is third angle projection system. The first angle projection system is very popular in European countries and also for ISO standards. In our entire course, for these NPTEL online lectures, we go with first angle system. Earlier days, it used to be third angle system quite popular, especially in Canada, USA, Japan, Thailand countries, they go with this third angle system. To know more about this first angle projection system or third angle projection system, first of all draw a three-dimensional quadrant system. Let us consider these are the axes which are going to define whether something is in first quadrant or second quadrant or third quadrant. So, let us construct a box which goes in that way. So, a box located in the first quadrant. Similarly, construct one more box in the second quadrant. And similarly, a third box and a fourth box. For drawing, we mainly look at either third quadrant or first quadrant systems. So, if the box is placed at the first quadrant system, in which if we are assuming another object is placed, something like the slot block, if we are trying to look at what are the views of that box, then that is what we call one of the quadrant system. In this case, this block is placed in this first quadrant. So, any views constructed based on that we call first quadrant. Similarly, if the block is kept in the third quadrant and if we are making objects observations from that direction, we call that one as third quadrant system. So, based on the observer, based on this observer, the views whatever we obtain, we call that as either first angle projection or the third angle projection. And these boxes whatever the first quadrant, second quadrant, these are imaginary kind of boxes. These are transparent in one of the planes and opaque on other planes. For example, if we are picking first quadrant system, it consists of in total 6 planes, 4 on the sides, top and bottom thing. For first quadrant system, the bottom plane always be opaque plane. Similarly, the back side is also opaque. So, one can't observe it from back side. Similarly, one can't observe it from bottom side. However, one can observe the object from front side, so that one will be in a position to sense the object shape follows these lines if one is looking at in that view. Similarly, if someone is observing it from top, that is also transparent plane. So, one might be in a position to observe the following lines, and one will be seeing these depth as lines. So, if someone looking from top, the highlight hash portion, these are the lines what one will be going to see. Similarly, if one is looking from this direction, this one always be opaque on the back side, but this one is transparent wall. So, one can really look at from transparent wall, what they will see is object as these lines. So, this line entirely coincides with this point. and again one will be seeing this coincided point. For view they will see something like this. This line will be just a line and again coincidental line. Here again one will see that line. So, these are the lines what one will see in this projection from the side views. So, here in that orthographic view, so these projections what we are calling onto the planes, onto these opaque planes, what we call generally orthographic views. In the perpendicular direction to that object we are trying to look at. Observer whatever he sees by projecting lines is more like if you have a lamp, whatever the shadow it forms and precisely the shadow behind the object, the way how it looks like, that is what we call these orthographic views. So, for example, for the same object, if light is passing through the eye, if we are observing, for this, though the object might be slightly having complicated shape, but we will see only like that L shape for the projection. This is what we call front view. If we are looking from top, observer is this. So, this line what we see coming from this line. This line comes from this line and this one comes from that line. Similarly, this line comes from this line. This part coincides, so we do not see anything depth, and this one follows that one. Similarly, from top if we are looking, that top line coincides. Here there is something like a step from top level all the way to down we are seeing. So, that line coincides with this line. So, we see it like one single line there. This bottom one, this one and this top one, bottom one coincides and we see this entire line as this one. Similarly, this line we will see it as that there is going in that direction, that goes in that way and it goes up, comes there. So, that comes in that way. This is the way we look at these observations, the projections or orthographic views. Similarly, if we are looking from this side where observer is present, naturally the front one here we will see it here. This one goes like a step, comes out. So, that one comes out like that and this entire line coincides to that point, it goes all the way up, it goes up and after that on top whatever that we see, that will be coinciding with these lines and this goes down. So, that one comes in that way. These are the ways we look at orthographic views in first quadrant system, where the side planes are opaque, the bottom plane is also opaque plane. However, the frontal ones, this is transparent direction, this is also transparent direction, this is also transparent direction. Let us look at third angle projection system. The observer direction is transparent. For example, here we have observer watching in that direction. Similarly, observer is watching in that direction, observer watches in that direction. Onto that direction, if we are projecting whatever the thing we are going to see, that is what we call third angle projection. Here the object, if we are looking the same object, the L shape comes from projection of that one onto this plane. Similarly, projection of this plane onto that observer direction, we will see this view. Similarly, the object projected onto the plane where observer is trying to look at, again one more view we will get. Such kind of things what we call third angle system. So, in this third angle system is more like transparent planes and glass boxes are intermingled with each other. Here in the first angle projection, size always be, or the views on which we are going to project, those will be opaque and the direction through which we are going to see will be transparent. So, because of that easiness, usually we go with first angle projection system. Anyone can go with either of them. One can use first angle and also third angle projections, but these days usually people are going with a standardized protocol like first angle projection. So, throughout our course we go with first angle projection. There is nothing like this method is advantageous, that method is disadvantageous. It's just one protocol. Because of easiness in observing these planes, we are going with first angle projection system. Once these observations are done, we have to represent that on the 2D sheet. Constructing 3D objects on drawing sheets means we are going to induce aberrations like converging, diverging kind of things. To avoid that, these views gives complete details about the object. So, we project these objects onto those planes, particular opaque planes, then flip the sheets to construct that onto 2D sheet. Let us look at those orthographics in detail. So, here on the drawing sheet, using first angle projection system, we are going to construct these views. The object somewhere kept at middle, and after projections we got something like orthographic views in that way. For this one, similarly, the side view what we got is this one, and the top view what we got is in that way. The standard procedure is first decide the vertical plane front view, after that go with the top view on that horizontal plane, after that construct a view, side view, profile plane view. So, here left side view we will go ahead, construct that and represent that. This is the way we go ahead. So, once these views are obtained on these orthogonal planes, what we do is we represent this one plane, the red plane, let us consider on the drawing sheet. If this is the drawing sheet, we first of all show this plane and the object on the vertical plane, and this is front view, because the first one what we are observing is in this direction, front direction of the observer, whatever it is present, that is what we call front view. Then we take a cut of that, these are imaginary kind of cuts, so that I can flip this page all the way downward direction. So, the view what we are getting is top view, and what we are trying to construct is make a scissoring kind of thing here and flip it in the 90 degrees downward direction. So, that we are going to construct flip plane as that, the yellow one or the mustard color. After flipping, making a scissors in this direction, making a scissors in that direction, folding it in the 90 degrees by 90 degrees, what we will going to see is something like a red one. If we are folding it in that direction, it is supposed to come here, flip this one also 90 degrees, so that this will come here, folding frontal plane, this is the front view, this is the top view what we will see, and the rest of that as it is. So, this is the way we generate the views of the object. Similarly, if we are making third angle projections, for third angle thing, if we are making a scissor in this line and flip it a folding line around that direction, this entire object comes to this location. Similarly, this entire projection, because we scissored here, I can flip it in that direction, fold it. So, if I am making that fold by 90 degrees around this line, then this projection comes to this level. So, let us draw the views. One of your view is this, the other view is this. The rest, which is fixed because we are observing in that direction. So, the front view comes at this level. So, we will see in third angle projection, the top view now placed at this level, the front view placed at this level, and the side view whatever we flipped it, it comes in that direction. In the earlier case, in the first angle projection system, this is the way we obtain these projections. After rearrangement of these orthographic views on the first angle projection system, we see it an object. If we are looking at in this direction, let us look at observe the views of this object. For example, observer is at this location, the object is that. We would like to view front view. If I am deciding this will be my front view. Later we will learn about the rules, which one to be picked as front view, which one to be picked as top view, and which one to be picked as side view. Usually the details which are available many that direction, we will pick it as frontal view most of the times. So, once this is the front view, direction is given by arrows, usually on drawing sheets. If you are observing, there will be a arrow which usually indicates that the front view direction supposed to begin in that direction. So, here let us assume that front view direction is observed in that way. If that is the case, what we are going to see is this one. So, this rectangle we will see which goes like a line, and this line maps to this line. So, maps there. So, what we see is a small rectangle followed by a large rectangle at the front view location. Similarly, on top of that we are going to see this object. After constructing front view, we have to see it from top view. Now, the direction for front view is this direction. So, normal to that direction, if we are observing this, what we are going to see is this part and this part. So, this one coincides with this one coincides with that one. So, what we are going to see is this one. So, first we see that the direction is in that way. So, what we have to look at is onto that plane, if we are looking at a projection, whatever it is happening, that we are going to see it. That after folding it into that direction, we see it in this way for the top view. Now, side view, because this is front view, this is top view. One can look from back also, but in first quadrant system that is a opaque plane and the transparent plane is in this direction. So, if we are looking at that, the side view of this entire object maps here, because now this is the direction for front view direction, this is the top view direction. From right side we are trying to project it onto the left side. So, that view what we are calling a right side view. So, right is projected to left. So, right side thing we are projecting onto the left side. So, naturally on the left plane will be opaque and we are going to get that view. So, what we are going to see is projection 1, this one. This entire plane, these points everything mapped under this one, because there is a line which is going as a cut all the way down for this. So, usually we represent by dashed line in the picture. Instead of saying that this is a complete block, if it is a complete block there is no line behind that, to just indicate that we represent that cut by a dashed line. If you are looking from front view, there is a line which is visible, it is a cut, but still visible, that is the reason we show it by a continuous line. However, in the side view what we are saying is there is a cut, but we can't view it if we are projecting it. So, we just to represent that intricate dimensions or directions also we are showing it by a dashed line. In the third angle system, these views will be alternatively arranged. So, the first front view whatever it is present, that comes at bottom level. In first angle projection system, it is recommended to have front view at top, top view below that and right side view connected on this front view. So, front view is the central one that will be connected by top and right side views or perhaps left side views. Whereas, in third angle system, third angle projection system, what we see is for the same object the front view comes at bottom level, top view goes to top level and right side view comes to right hand side. In the next class, we will learn more about projections of the system.